Join us as we bring you a new way to travel faster than light. Before we start, hit the red subscribe button so that you never miss out on any of our videos. When you want to travel a long distance, say from one continent to another, you take an airplane and expect to spend several hours in the air. However, when it comes to space travel, it's important to travel much faster because the points of interest are extremely far away. Space explorers have always been searching for a way to travel faster than light, which will allow them to get to deep space quickly. Essentially, all the methods discovered so far have significant drawbacks, but scientists have found a new way. How does it work? What are the requirements? How soon will you be able to travel with it? Light is fascinating and very important because without it, it would be difficult to watch this video. You have probably heard that light travels extremely fast, but how fast is light? Interestingly, the exact speed of light is known and is the basis for most other measurements. The speed of light traveling through a vacuum is exactly 299,792,458 meters, or 983,571,056 feet per second. That means light will travel about 186,282 miles in just 1 second. Light is so fast that if you switch on a bulb in a dark room, the light fills every spot in the room almost instantly. Another unit of measurement involving light is the light year, which is the distance that light can travel in 1 year. This value is about 6 trillion miles or 10 trillion kilometers. It is one way that astronomers and physicists measure immense distances across our universe. As mentioned earlier, the universe is so vast that it can take light many years to travel from one part to another. To illustrate this, light travels from the moon to our eyes in about 1 second, which means the moon is about 1 light second away. However, sunlight takes longer, requiring about 8 minutes to reach our eyes, meaning the sun is about 8 light minutes away. Light from Alpha Centauri, the nearest star system to our own, requires roughly 4.3 years to get here, so Alpha Centauri is 4.3 light years away. Other stars and objects beyond our solar system lie anywhere from a few light years to a few billion light years out. This is why seeing everything astronomers see in the distant universe is literally history. When they study objects that are far away, they are seeing light that shows the objects as they existed at the time that light left them. While there are a lot of fascinating things you can do with light, scientists have tried to find a way to travel at the speed of light. This is interesting as humans will hopefully soon become an interplanetary species. For instance, SpaceX billionaire CEO Elon Musk wants to form a settlement on Mars, but his explorers have to bear at the minimum 5 months of travel through space before touching down on the red planet. This can even reach almost a year, depending on how close the two planets are. And that is with all the hazards it brings before touching down on the red planet. However, with speed of light travel, they can make the long trip in less than 4 minutes. Researchers have tried many different methods to achieve traveling at a very high speed. There has always been a problem that all other methods could not solve. Even to achieve 1% of the speed of light, which is still plenty fast as it can take you from Los Angeles to New York in a little over a second, is very hard. The problem, in a single word, is energy. Any object moving has energy due to its motion, and physicists call this kinetic energy. To go faster, you need to increase kinetic energy. The problem is that it takes a lot of kinetic energy to increase speed. To make something go twice as fast takes 4 times the energy. Making something go 3 times as fast requires 9 times the energy, and so on. For example, to get a teenager who weighs 110 pounds to 1% of the speed of light would require 200 trillion joules. That's roughly the same amount of energy that 2 million people in the US use in a day. Take, for example, the M drive, which was touted as the technology that would take us to the most distant parts of the universe very fast. This invention, which has even been patented, theoretically works by trapping microwaves in a shaped chamber where their bouncing produces thrust. The chamber is closed, meaning from the outside, it will appear to simply move without any fuel input or any thrust output. The M drive relies on Newton's second law, where force is defined as the rate of change of momentum. Thus, an electromagnetic or EM wave traveling at the speed of light has a certain momentum that will transfer to a reflector, resulting in a tiny force. This accumulated tiny force in great quantity is what enables the M drive. This sounds simple, but it also turns our understanding of physics on its head. No energy is going in or coming out, which makes us ask questions like, how are the waves initialized? How do they continue to move? And where is their momentum coming from? You can't have spontaneous created momentum without an explicable push, which is why many scientists don't even take the M drive seriously. If the M drive works, then it invalidates much of what physicists know about the universe. The M drive was even put to the test by physicists at the Dresden University of Technology that showed the promising results obtained by NASA and Chinese showing thrust were all false positives explained by outside forces. However, the warp drive shows great promises as shown by Dr. Eric Lentz, a physicist with over 10 years of experience in practical applications. Lentz wasn't even the first to work on making the warp drive a reality and not just sci-fi. However, their model could not go beyond the speed of light, which is the holy grail of space travel. Well, that's all for today. I hope you enjoyed the video. If you did, make sure to hit that like button and subscribe to Curiosity Lounge so that you never miss any amazing video from us.